Welcome back student. In basic chemistry course, in previous session we discussed the different methods of protection of metal from the corrosion. There are generally 4 methods. So out of these 4 methods, in last session we discussed first 2 methods, that is modification of environment and modification of properties of the metals. In today's session we discuss the third type of method which is used for protection of metal from the corrosion is electrochemical protection method. So this electrochemical protection method, that means we make the metal as a cathode. Let's discuss. So this electrochemical protection will be carried out by the 2 ways. So first way is the sacrificial anodic protection and second method is by impressed current cathodic protection. Okay, so let's discuss the first method, that is sacrificial anodic protection. So in this protection method, the metallic structure to be protected is connected by a wire to more anodic metal. Hence, all the corrosion is connected at this more active metal and the less active metal which becomes act as a cathode and it becomes protected. So, in this method, generally we use the more active metals. So, these more active metals are generally magnesium, zinc, aluminium. These more active metals in electrochemical series will be used as a anode. So for example, so in underground areas have a pipeline is there, steel machinery or there is having a pipeline. So we have to protect this pipeline, underground pipeline. So in this we use one of the metal, it becomes act as an anode. So that's why we use the more active metal. This is the magnesium, zinc or the aluminium, and they will be connected to this pipeline. So that's why the more in this pipeline the more active metal becomes is this one, more active metal becomes this one, and this pipeline will be act as a cathode. So that's why the loss of electrons will be takes place at these more active metals, that means at anode. So that's why their corrosion can be carried out, and this pipeline will be less active. So that's why they becomes act as a cathode and they get protected from the corrosion. So in this method we use the anode, this anode which becomes sacrifice and act as a anode. So that's why this method will be named as a sacrificial anodic protection. Is used to protect the burette, the ship hulls. Also this method is used to protect the burette pipelines. Also they will be used in marine structures also, and also they will be used in underground for the protection of underground cables. So in these methods, this method is generally used in these different field. So these ship hulls will be generally underground in water. So this underground part of this ship will be in contact with the water. So that's why they becomes act as an anode and they have a corrosion can be carried out. So that's why for the protection of this ship, having a different metal part will be also of the ship metal. So that's why this metal which becomes more active. So that's why this metal which becomes act as an anode, and the ship hull part that time they becomes act as a cathode. So that's why, and that time they can protected from the corrosion of the ship hulls. Okay, so let's discuss the second electrochemical protection method is impressed current cathodic protection. So in this impressed current cathodic protection method, the impressed current is applied in opposite direction to nullify the corrosion current and convert corroding metal from anode to cathode. So thus it is protected. So generally in this impressed current method, so that's why we take this example. In this example also the underground pipeline is there. So this we can protect this underground pipeline. So that's why this underground pipeline part will be connected to the another metal which become and they act as an anode. But in this method, this metal which becomes a graphite and backfill is there, and this backfill is filled with gypsum, and this anode which becomes begin to start corrosion. But at that time we have to protect this anodic part. We electrons can lose at this anode and they becomes transfer from anode to cathode. So at that time there is having a corrosion current is there. When the corrosion can start at the anode, that means the corrosion current can be carried out. But for the protection of this anode, we can use the impressed current. That means this impressed current to oppose this corrosion current. And so that's why the impressed current can oppose this corrosion current. So that's why this current can nullify. That means the electron transfer cannot be carried out and stop the corrosion of this anodic metal. So that's why this method will be called as the impressed current cathodic protection. That means this anode which also become act as a cathode because the current can nullify. So that's why this anode will also act as a cathode and they can be protected from the corrosion. So this method will be also used to protect the water tank, buried oil pipelines, water pipelines, open water box cooler, condensers, transmission line towers, and marine structures. So this impressed current cathodic protection, electrons are supplied from an external cell, so that's the object itself becomes cathodic. So that's why this anode which itself become act as a cathode. So that's why they cannot lose their electron and they cannot corroded. Okay, so this is the impressed current cathodic protection method. So next, fourth method we see here for the protection of metal from corrosion is application of protective coatings. So in this application of protective coatings is very useful to minimize the corrosion of the metals. So there are generally of two types of coating is there. First type of coating is inorganic protective coating. Second type of coating is organic protective coating. So we discuss these two types of coating one by one. So firstly we discuss the types of inorganic protective coatings. So these inorganic protective coatings are of three types. So first type of inorganic protective coating is formation of oxide films. Means the oxide film formation will be carried out to protect the metal from the corrosion. Second type is a phosphate coating. So phosphate coating will also used to protect the metal from corrosion. Third type is metal coatings. And this third type of metal coating will be also of having a two subtypes. First type is coating of less active metal and coating of more active metals. Means the metal coating will be carried out, but we use the metal will be either less active or either more active. They will be become divided into two types. Okay, so first type of inorganic protective coating is oxide film formation. So this oxide film formation, so in this type the more active metals, we already discussed the more active metals are aluminum, zinc, nickel, tin, chromium. They will be present in top in electrochemical series. So that's why they becomes act as a more active metals, and the noble metals will be present at the bottom layer of the electrochemical series. So that's why these metals which becomes act as a less active metals. So in oxide film formation we have to take more active metals like aluminum, zinc, nickel, tin or the chromium to form the insoluble oxide film on the surface of metal. That means this is the surface of metal. So this surface of the metal, this and this metal which becomes more active. So the more active metal having a surface which come in contact with the atmospheric oxygen and to form the film of oxide. and to form the film of oxide. For example, we take this metal which becomes aluminum and they becomes contact with the atmospheric oxygen, and to form the film of oxide is the aluminum trioxide. So this aluminum trioxide film which becomes non-porous, we already discussed in our last session. So this is a film form on the surface of this aluminum metal which becomes non-porous. So that's why this oxide film, that means the more active metals formation of oxide film, this film becomes non-porous, that means this film becomes protective and they can protect this further metal from this metal from further corrosion. Okay, second type is the phosphate coating. So in the phosphate coating, the insoluble ferric phosphate is to be formed on the surface of iron. For example, we take the piece of iron, this is the piece of iron, and this is a piece of iron we can dip in a phosphoric acid. This piece of iron will be dipped in a phosphoric acid. Phosphoric acid. When we dip this phosphoric acid, when we dip this iron piece in phosphoric acid, then that times the insoluble ferric phosphate is formed on their surface. So on their surface of this iron, insoluble ferric phosphate will be formed on their surface, and this film becomes insoluble. So that's why this ferric phosphate which adhere this ferric phosphate which adhere to the metal surface and protects the metal from corrosion. They can adhere means they can tightly fixed on the surface of this iron metal, and they can protect this below part of the film from the further corrosion. Okay, so this is the phosphate coating. Next we see the metal coatings. So this metal on the surface of metal means the one of the piece of metal will also coat on other metal. So this piece of metal will be coated on the other metal. So this metal which becomes less active or the more active. Okay, and they can protect from the further corrosion. So this topic we will discuss in next session. So today we will stop. Thank you.